Okay, welcome to this explanation video about my RC car. So to give you a little bit of a backstory, I've posted this on Reddit and a lot of people asked me how I made it work, and so I thought I would make this explanation video about it. So yeah, let's start by taking this off so you can see inside it. Okay, now that we can see everything, let's talk about what you need hardware-wise to get this done. So the first thing you obviously need is an RC car. It really doesn't matter which one or which kind of RC car, but I would recommend something that has quite big wheels, because something you have to deal with is the vibration of the camera. And from my experience, bigger wheels cause less vibrations, and this is way better. It will give you a way better visual image from the camera. And something very important is that you need an RC car with standardized components, because if you have one of those really cheap RC cars, everything will be managed by just one controller, and it will be super hard to figure out how those proprietary components work. So I would look for those kind of connectors on the components, like that the servo you use to steer and DST for the motor both have those kind of connectors. Okay, if you got your RC car, you obviously need a Raspberry Pi. This would probably work with any kind of small computer, but the Raspberry Pi works really well for it. I'm using the Pi 4, but pretty much anything should work since you really don't need much of computing power. Then you need a Raspberry Pi camera. I've also tested several, but I would go with one that has quite a big field of view. This one has, I think, 180 degrees, and you can just drive it way better because you see all around you, and that really helps you while driving. Now, let's talk about power. So here you really have a lot of options. Probably the simplest option you can go with is just using a power bank besides your battery for the motor to power the Pi. However, I've had some problems with that because power banks seem to not give quite enough power for the Pi to drive the servos. So sometimes when I would steer, the steering wouldn't work. So I would recommend something else. And the first option I've gone with was using an Arduino. So an Arduino can take a 12-volt power input. I've took this straight from the battery here. And then it can output 3-volt powers through its pins. And this is pretty much what I've done here. I've just used the Arduino to power the Pi. And by using that, I've always had a really good response on the servos. Okay, now, something else I want to show you about power is this device here. I haven't tested this yet, but this should give you a really clean solution. So what this does is this takes just some standard 12-volt battery, or I think it even works with 7 volts, on one side, and then it outputs to 3-volt USB on the other side. So this should work as well. Something else you can also use for a better experience while driving is using some kind of a servo tower to look around with the camera. So as you can see, I have 2 servos here, and this just allows me to tilt the camera and look around, do whatever I want while driving. This really helps because if you're driving, like for example on the road, you might want to look out for cars, and this really helps. It just gives you a way better overview of things. Okay, everything I've showed you so far will make the car work, but it will only work in your local network, meaning you will need some kind of Wi-Fi or Ethernet connection for it to drive around. So obviously this is not ideal, since you will only have Wi-Fi inside your house. So if you want to go further, you will need an LTE connection, meaning you will use the mobile network to connect to the internet. The Pi itself doesn't have the hardware required to do this, but there are ways. One of those ways is something like this. This is a mobile network dongle. The way this works is you can insert a SIM card in this device, and then it will serve internet over USB. So you can just plug this into your Pi, and then the Pi will have LTE network, just like your phone. However, you will need to consider a few things before you can start with this. The first point is you will need unlimited internet on your phone subscription, because the camera stream will use a lot of bandwidth and you will run out of your internet budget very fast. I don't know if you can say it like that. I'm just gonna leave it like that. The second thing is you are very reliant on your LTE coverage in your area. So I would recommend to find out how well your 4G network is established in the area you want to drive the car. Here in Switzerland, the providers have some kind of maps on the internet where you can just check how good the connection is in a certain area. I don't know if this exists anywhere, but I would really check this beforehand, because if you buy all of this stuff and then you don't have any connection, it was obviously quite a fluke.
Okay, so now that you know what you need to do this whole thing, let's talk about what you actually need to do to make this work. So in the center of it, we obviously have your onboard computer. Again, I did it as a Pi, but it should work with pretty much anything else. And this computer has to do two things. On one side, it has to communicate with your server. And this obviously should be as fast and as responsive as possible. And what this communication has to contain is, on one direction, you send your current video and some telemetry you might want to send to your server. I personally did this with Socket.io and a UDP socket. I will tell you more about later. And for the video, I've used Raspberry Bit to capture the video and then a package called Socat to stream it over UDP. And then the controls, in my case, I've just used JSON data and I sent that over UDP sockets. On the other hand, you have your hardware. As you can see, all the hardware is connected over the GPIO pins of the Pi, and that's pretty much how I did it. You can control pretty much any servo and ESC over the GPIO pins, so I would heavily recommend to do the same. To control the servos and the ESC, I've used the Pi GPIO package. There are a lot of ways to control GPIO pins with code, but I found this Pi GPIO package to be very useful because it somehow seems to reduce the servo stutter a lot. So when I've used like the default GPIO package, my servers used to just go crazy and stutter like hell. And when I've switched to this package here, it got a lot better. So I would very highly recommend this. How can you actually connect a servo over those GPIO pins? It's actually very simple. So as you can see on the left side here, I have a map of those pins. And if you don't notice, you can see all of those pins have a specific function or something they're designed to do. We have power pins, ground pins, some reserve pins you can use, and then we have a lot of GPIO pins. And those GPIO pins can all be used to work for you basically. So you can tell them what signals they should send. And that's what we're going to use here. As you can see, I've connected the ground and power to those two corresponding pins, and then I've used this one GPIO pin for our signal. And here is where the data used to control the servo will flow. And the data you're sending is, once again, pretty simple. Servos work with something called a duty cycle. This duty cycle tells the servo which angle this little rudder here has to go to. And the way it works is 500 is fully to the left, 1.5k is in the middle, and 2.5k is fully to the right. However, different servos have different duty cycles. Sometimes the range is different or something else is different. However, you can just try it out. So if this range here doesn't work for you, just try some different range or try to Google it. You find most of those informations about specific servos online. And for your ESC to control your motor, it's the absolute same. So you once again power it up. However, sometimes it is not recommended to actually power the ESC over your Pi because it will be powered already by your battery. And I've read online that some people had their boards fried because they connected this 5-volt pin here. So maybe Google this or check this beforehand because it can really kill your board. In my case it wasn't a problem, but it might be for you. And then once again, we connect this signaling pin here, and then we just initiate our ESC the exact same way like we made it with the servo. And as you can see, those ESCs also work with duty cycles, and it is once again pretty simple to control those. Now let's talk about how you will record and stream the video from your Pi. And I've got to warn you, this is where it gets a little bit more complicated. So basically, how it works is by using this command. It uses Raspberry to access the camera and then tell Raspberry to output the camera data into your output stream. We then use this pipe here to pipe it into our other package called SoCat. SoCat will then receive this data, and then we can tell SoCat to send it via UDP to a certain host on a certain port. So we use Raspberry to record, stream it to SoCat, and then we use SoCat to stream it over the network. Now, because I don't want to manually enter this command every time I use my car, I use Node's child process module to kind of spawn a subprocess that then streams the video for me. As you can see, I've also added a lot of options in here, for example, width, height, FPS, bitrate, brightness, and so forth. So you now know how you can control servos using code on your Pi. But that's only half the problem, because you will somehow need to send your controller inputs to your Pi so you can then use them to control your servos and motor. Question remains, how are you going to do that? Once again, you have a lot of options. However, I would highly recommend not to use Socket.io for that. Socket.io is the obvious way, but since you won't have a very fast connection on your car, you will have a lot of lag when controlling it. So, in my opinion, the best way is using some kind of UDP socket. The most obvious choice here is Node's internal dgram module. This is super fast, works really well. However, you don't have a lot of features. So for example, the server only has one single event for packages, and this is just the message event. So every package you will send will just pour out of this message event emitter, and that will get things really messed up. I've also had this problem, and so I developed this little library here. What it does is it gives you pretty much all the functionality Socket.io has to offer. But it's not HTTP sockets, it's UDP sockets. So it's way faster. But it won't work in your browser because browsers don't support this. However, you can use it to send data from your server to your car and from your car to your server. And since this is the connection that will be slow, it kind of only makes sense to use it that way. So how does it work? As you can see, here we don't just have this message emitter, we have pretty much every emitter you want to set. So if you've already used Socket.io, this should be super easy to understand. If you have never used Socket.io, I would highly recommend to just look into that. And then you can also take a look at the README file from this UD Plus library on npm here, and you should be able to get this thing to work. Okay, so you should now know the basics about this whole thing. You know how I send the data from my server to my car, you know how I control the servos, the SC, and you know how I used this socket package to stream the data to the server. What I would like to do right now is get a little bit deeper into my personal code I've created to run this whole thing. So if you want to, you can use my own code, and understanding those certain elements of it will give you quite an easy start into it. So as you can see, all the communication we have has to go from your browser to your server to your Raspberry Pi in your car, or the other way around. But it's always this chain of stations these signals take. So in this example, we have a controller input that leads to a servo output on your car. It starts here when we use Socket.io to emit our gamepad controls to our server. We can then see that this socket emission we do here leads to a event on your server, and the data we send here, more specifically the axes and paddles and buttons we have on our controller, will then be emitted on our server. What we then do with this data, we just send it straight our UDP socket to our car. It then arrives here, emits another event, and it's kind of the same thing, but in this case we don't just keep sending it, we use it to update our controls. And as you can see, what I do here is pretty simple. I just take this servo I've created before, and then what I do is, because the controller doesn't work with duty cycles but with axes, I've created this little toCycle function right here. It's really simple. What it just does is it takes a value between -1 and 1 and calculates it to a duty cycle so the servo can work with it. And then we just send that straight through our pin to our servo, and just like that we can control our car through our joystick on our web browser. Now for the video stream. The first thing you will notice is that obviously it's the other way around. Here we start on the Pi, and as I've explained before, we're using this Raspberry and the socket module to stream our data. Then on our server, if we have entered the right port and host, we will receive it on this event emitter. As you can see, the emitter is called raw. This is because the certain custom event emitters obviously only work if we send from a UD Plus client to a UD Plus server. And here we're just getting a raw UD Plus package because the socket module obviously doesn't know about my UD Plus module. So it just arrives like that on our raw event emitter. And what we gotta do then is, and here I've gotta be fully honest, I don't know why this is necessary, I don't know what is happening here, but for some reason it needs to be split up. So I've used this NAL splitter module to split the data, I don't know, and we can write it to this module then, and this module has then its own event emitter, and as soon as it thinks some new data has arrived, it then emits its own event with the new split up data. And here you'll probably notice that I'm not a pro at this, so yeah, if you know what it does, tell me, I would be really interested, but I honestly have no fucking idea. But it doesn't matter, because all we do now is we emit it over Socket.io, So we send it now from the server to our web browser. In our web browser, this beautiful data arrives, and now we just gotta convert it into a unit 8 array. Once again, I don't have a clue what I'm doing, but it works. Here I'm just capturing some stats for my overlay, really not necessary, but the important thing is then we use this thing called Broadway. What this can, it's a library for your browser, and it can render H.264 encoded data. So this little guy here, he sends us an H.264 stream, and we use the Broadway player to decode this and display it in our web browser. What I really like about the solution is, first of all, we don't need to like convert it into MP4 on our server or something like that. We can just send it straight through, and this results in a really good latency. The downside of this, however, is that this Broadway decoder won't work in every browser. I've tested it on Firefox and Chrome, but for example in Edge, I think it wouldn't work. So you'll need to do some research there, but I would highly recommend to do the video streaming as described right here, because I have tested so many ways and this is by far the best working one. So now you should pretty much know all you need to get this whole thing started. There's however one last thing I haven't talked about so far, and I would also like to not explain the whole thing because it's just so much, but it should be really easy to figure out for you if you can access my code, but you can. And that is the terminal that I've implemented on the website itself. I would highly recommend you to do the same if you're doing your own code, because what you'll be doing all the time is trying to figure out things and fix things while you're driving the car. And since you most likely won't be in your home network, you won't have any way to access the command line. And as you can see in the video right now, I have implemented this little terminal that works just like a normal SSH terminal, and it's just so useful to debug things. So once again, highly recommend implementing this in your own project.